Hello everyone, welcome to this training on Exa Cloud Service APIs and CLIs. My name is Bal Sharma. I am part of Oracle Cloud Infrastructure Product Management team. Before I proceed, I will take a pause here so that you can read the safe harbor statement. So objectives for this lesson is going to be around the APIs as well as the CLI which are provided by Exa Cloud Service and which are applicable to Exa. We'll try to understand the different APIs like Debus API, Exa CLIs, Debus CLI, and what kind of operations they support. We will also learn on how to set up OCI Commandline Utility and various functions which are supported through OCI CLI as well. We will also take a look at Exa CLI, that is known as Exa CLI, and various examples of that, which helps you basically administer the storage cell, right? So we don't have direct access to Exa storage cell, and in those cases Exa CLI becomes handy. And we'll also get into a demo at the end of this session to see a few of these operations in a live environment. So taking a look at various command line utilities, CLIs and APIs, we have basically 4 of them. So Debus API, which helps for managing the database lifecycle management kind of operations. So that might include creating an environment or deleting and dealing with those kind of operations. The another one is Debus CLI, which helps with database lifecycle related to encryption or related to home maintenance or doing operational activities like controlling the listeners and things like that. PDB lifecycle management can be done. You can also use Debus CLI to perform the patching operations. And another utility which is provided here is Exa CLI, and the Exa CLI is going to help us with looking at various storage cell matrices as well as diagnostic information. Backup API we have already covered in backup and recovery course. So if you have not seen that, you can take a look at there. We have discussed all the operations supported by backup API for applying a patch or like doing a precheck and rolling back a particular patch. So these are mostly 4 utilities, and apart from this we have OCI CLI. They also provide several kind of facilities which helps you manage the Exa cloud service environment. So OCI CLI, I have not put it on the slide, but I will be covering that also in detail on how to set it up and perform activities which are applicable to Exa CS, like scaling it up or scaling down, or even like looking at the patching kind of activities. So we'll get into these in more detail. So the first one, like I'm going to start with his Debus API, and Exa database system include these command line tools for performing various tasks. So one of the tasks could be like adding a database or removing a database from the Exa database system. So Debus API can be used to create and manage databases in Exa Cloud Service, and all of the calls to Debus API will be via an input JSON file, and the output is also going to be a formatted JSON file. So the syntax looks like you will be executing it from var opt Oracle, where you have a folder called Debus API, and Debus API binaries would be there. With that, like you are going to pass a JSON input file. So all calls are going to be asynchronous, except when a status is requested, that will be the synchronous operation. So there are several common parameters which you need to know in order to use Debus API. So object here means a target object for current Debus API process to be triggered, like database could be an object, or operations could be like what you want to do on the database, whether it's a snapshot or clone or backup. Actions could be related to like end or delete or begin. So they will be the values for the action performed, and params can take a kind of nested JSON object for operation specific parameters. So it expects the DB name for your database names, and node list could be the compute names where your database instances are running. So in case if you have a rack environment, then you need to pass that with comma separated. While dealing with Debus API, you need to also specify out files, and out file is going to be the absolute path to file write basic output from the current operation. So it's a kind of log of the activity which you are going to perform, and you can optionally include flags for additional debugging. So let's get started with Debus API. This is a command line utility for doing operations like create and delete databases on Exadata database system, and it is located with, under var opt Oracle directory on the compute node, and it should be run by the root user. So you must update the cloud specific tooling, and this is a general guideline we give, especially if you are going to deal with these APIs and CLI. Even for Debus CLI, you have to make sure that cloud specific toolings are all up to date. And if you want to learn more about how to update the Exadata database system, the link can take you there. And another ways, like there are several ways to update this tooling. So using Debus commands, Debus CLI, you can do that one, or you can also use through xrdbc patch multi commands. So that also provides you a way to update the tooling in place. So only one Debus API operation can be executed at any given time. So Oracle recommends that you should also do a check of the status of any operation you are invoking using Debus API before you want to run any another operation. So now we will try to cover a use case like creating a database, and to get started, we will create a directory which is going to hold all of the scripts for using this command line utility. So we will create a directory called as db input. We will have an input file. In my case, I'm going to give it a name. You can give any name. My input.json, and a simple output file which will be created as createdb.out. So for performing this, you need to SSH to the compute node in the Exadata database system with OPC user, and then you can sudo to root user, create the directory, and create this particular input file. So in this example, what we are going to take a look at, we will be creating a database which is also going to use the backups on existing bucket within object storage. So in Exa environment, you might have already done it, like your backups will be going to both local as well as the cloud object storage. So you can additionally see for more details on the parameters under this link, create database parameters. We will be running the utility and specify the input file, and then we will check the output file, and from the output file, the only important portion is going to be the ID of that particular operation. So we'll create another JSON file to check the database creation status, and you will have to see the status replace the ID with the previous step for the database name. And we'll run the utility with the status file as input and check the utility output. And these commands you can run several times until the operation is succeeded or failed. So in example, I have a myinput.json file, and this JSON file has several entries, and since I want to create a database, I'm giving object is going to be of type DB, and the action will be a start, and operation is create DB. So these are the parameters we initially discussed, like Debus API expect, and different params under this operation is the node list. I'm just leaving it blank because this is Exa environment. I have multiple nodes. I want this database instance to be created on both. DB name I have specified as ExaDB, The edition of database is E_EP. So that is the only version available on Exadata Cloud Service, extreme performance version. Then a version of the database you need to specify. You might be having several database homes already created on your Exadata Cloud Service environment. So these homes could be anything between 11.204 to 12.1.0 to 12.2 and 18C. So select your version. You need to specify the admin password. So this password is going to be a complex password you are going to set. The service identifier, the PDB, is the mandatory parameter on a multi-tenant container. But there is a way, like if you want to create a non-multi-tenant based database, that is also supported on Exa, and there like we will specify that CDB is going to be not present there. So we'll cover that example later, but in this example I'm creating just a container database with PDB name as PDB1. You need to also specify the character set and details, and in the last section, if you see here, I'm specifying backup destination as OSS. So OSS is nothing but it's object storage on Oracle Cloud Infrastructure. And if you provide that, you need to specify your container URI. And I have a bucket which is already created on this object storage, and I'm going to use the same bucket. You will have to also provide your storage user who has access to this bucket, as well as the auth token which you must be having. If not, you can take a look at your backup configurations and you'll be able to find that out, or you can generate a new token and then pass it over here. And yeah, at the end, like I'm specifying the output file, which is just going to be create_db.out, so you can give the name or the absolute path of that file. So once you do that, basically it will start writing to create_db.out, and you would be able to open that file create_db.out. And the important thing, as we discussed, you need to take ID value of that particular field, and that you are going to use for monitoring or tracking the status of that operation. So create a status file, like again you can use the same directory. I have created dbaasstatus.json file, and in the JSON file, if you'll see, my contents are object is db, action is a status, and operation is going to be create_db, right? So pretty much object and operations are same. The action, I'm going to find out what is the current status of operation, and then I'm passing the ID as I got from the previous step 41 here, and database name is ExaDB. So for this database creation, I want to track the status. And again, I'm giving the output file as same create_db.out, so this file will be overwritten. So run once you have created this JSON file, you can again use Debus API command with input as in this status.json file, and then you can take a look at the output file created in the same location. So that shows me the message is running OCD and object is database, status is in progress, right? There are no error. If in case of error, it will provide you the value. The output file is again the same directory, and this has also provided me a PID as part of the database provisioning. So this PID would be helpful for you to track it at the OS level, and action is now a start, and operation is create_db. So that way, like when you will run this command multiple times, you will see that the activity is completed, and then like you have ways to look at logging to your database. In my case, I'm taking a look at my pmon process, which was showing earlier nothing, right? It resulted this ExaDB process is not running, and then once the activity progressed, I am able to see the pmon process associated with my database. So it means that database is created. So This example is just showing the output of that one, so it's in showing still in progress and running the operation over here. So you can track, and this message is going to change, and you can also refer the following link over here, create database parameters, and that will take you through the different parameters which you can expect for the process. So now we will take a look at another example, creating a non-CDB database using non-CDB software image. So this particular feature was not present earlier. It is very recent feature we added to Exa Cloud Service. So now customers are able to create a non-CDB database. But for doing that one, there are certain steps which has to be performed. So you will have to make sure that you have the updated cloud tooling. That is the most important before attempting this operation. So in this example, we will be needing the Jan 2019 non-CDB software image, which has to be downloaded to software library. So as you know, like, we are not going to download any software from outside and putting it on XRCS. It is all APIs which are providing you or facilitating these operations, right? So for doing this one, definitely we will be using a CLI to get the latest software downloaded, and that will perform after updating our cloud tooling. So I might have another example which shows like how to get this software downloaded to the software library on XRCS. So I'm not getting into that one, but in order to complete how this Debus API would be able to do this one, like, just create a directory. Again, I have a DB input as my directory. I created a JSON file, and the only difference here for non-CDB database is, like, you have to make sure you set the CDB parameter to no, and the BP parameter, the bundle patch parameter, to the value that you use to download the non-CDB image for this. So backup sets can be set to OSS, which we seen in earlier example also. So this is what my JSON file has now. The CDB includes a value of no, and the bundle patch is Jan 2019, which I said supports a non-CDB database. So that value I'm passing here, and the remaining other things remains same, like you can give any database name. One thing, if you notice, like, there is no PDB and the associated values, as like this is going to be a non-container database. So once you run this step one, in step two, all Debus API is creating this out file, and out file has important information as ID, which will be helpful for tracking the status of this operation. So example continued. So you wanted to monitor the status of the create process by creating another JSON file containing ID from previous output and name of the database. So my status JSON file looks like ID is changed here, and database name I have given non-CDBA, and output file, again I'm passing the directory where this output file has to be written. So you can run this command multiple times, and you will see the values are changing in the output file. And in my case, if I query this file and looking at the status file, it shows me that it is running the OCD. OCD will be some of the utility or APIs inside, which will be called for creation of this database. So status is showing still in progress, and the output file and the PID of the process, and action source start, and operation is create database. So you can rerun this status command regularly until the response indicates that operation succeeded or failed. You can additionally track the monitor this activity with under log directory. So you will have a non-CDB folder, the database operation you are performing, and under Debus API you will have the log, and this log is going to be associated with the ID over here. So that tracks all the activity which are getting carried out internally, and this gives you a reference, like you would be able to exactly know how things are progressing through this API. So we have seen, like, till here, that two of the operation. One is like creating a database with multi-tenant database. Then I created a non-container based database, and now we'll be looking at another topic, means how we can delete the database again using this API. So normally Oracle recommends that you create a final backup before any delete operation for any broad databases, and then like these commands also are going to take an input as well as the output file. I will be creating a my input.json file and a simple output file like delete Exa for example, which I created earlier. So in order to do that, like logging to your Exadata system to root user, and then create the directories and run the utility, specify the input file. You'll be able to check the output file as we did with other commands, and note the ID and create a JSON file to check the database deletion status. So here the action of a status, action is going to be a status and replace the ID with the database name and the values from the previous step. And we'll be running this utility again several times to see how it progresses. And I have an example of this, which let me show you. So this example does exactly that. So I have a mydb delete.json file. Here object is database, action is start, operation is delete database. Params, I want to delete this particular database here in this example, val test, and the output is going to be written under home oracle delete exadb.out. So again, like once you run this, you have the output file which is created with the ID in place, and log file can be also tracked here, but we'll be creating the JSON file and tracking the action as a status here, and then like it when the things progress, like you should have the database deleted. So just to summarize, like what we are doing for using Debus API, for example, for creating a database, I created a JSON file first, ran the Debus API, checked the output file, and I found the ID associated with that. Then that was my first step, like creating JSON file, running the Debus API, and finding the ID from there. Then second step could be checking the status, and again, like it has three steps, like creating JSON file, run Debus API, check the output file, right? And even in deletion example, like we perform the same, like creating JSON file, running Debus API, check the output file, and check the ID. Then in second step, like checking the status of that one from the output file or from the log file, which shows over here. So with these examples, I will move to another utility which we want to discuss, and that is Debus CLI. And Debus CLI is for managing the lifecycle operation of database, and it's a command line interface for different tools which are used with Oracle Cloud Database. So not necessarily Debus CLI is very unique to Exa CS only. This is an API, and it definitely supports other databases, like it could be autonomous, or it could be another Debus or running on Oracle Cloud infrastructure. But we will take a look at what it can do in terms of Exa CS. But pretty much like all these operations are database specific operations are basically common, whether it's running on Exa or it's running on a normal VM or bare metal databases. So pretty much everything when it comes to managing the life cycle. Only thing, like this CLI takes input as like -- DB name, and you have to specify the database name with which you want to work. So we'll take a look at like how you can log in and start using it for activities, but on a high level, it covers starting or stopping of database, starting and stopping the net listener, viewing any information on Oracle homes, means you are listing the attributes. You can move a database from one home to another home. You can also delete or basically purge the database home which you don't need, and any database configuration changes can be performed. You can manage the Oracle database software image. So if you correlate, in my previous example in Debus API, I said that for creating a non-CDB database, you have to download the image which has ability to create this, right? And we downloaded a Jan 2019 some image. So that can be performed using this Debus CLI. So any software you want to bring to software library on XRCS, this utility command line interface is going to help. Another operations like managing pluggable databases or performing database recovery, you can rotate the master encryption keys. So anything you deal with your transparent data encryption can be done using Debus CLI utility. And for using this tool, it's really easy. Like we'll see how to get into this tool. So for connecting to Debus CLI utility, you have to connect to a compute node which are associated with Exadata cloud service deployment, and you can use Oracle user, but certain commands requires you to be logged in as root user, like commands using the DB home or DB image. So these commands are something like needs you to be as root user. DB home, any DB image, or if you are dealing any operation with downloading a software to software library or sub commands must be run with root administrator privilege. So in this case, like you are connecting with OPC and then you are doing a sudo to root. Debus CLI command basically takes sub command also, and this particular link is going to discuss more on this one. Here in this example, we'll cover a few of the use cases. Like for logging to getting to Debus CLI console, only thing you are doing is like just typing in Debus CLI, and it provides you the Debus prompt, and then there are several operations which we were discussing it supports. So just type help and it will show you list of operation it supports. So very long list. A few of these are like clean DB, enable, CNS, DNS disable, or DBA status, data guard related operations, avoided database move, change password, bounce the database activity. So this list is going to be long, so I've just I kept few of them here. Another thing we were discussing about like how it can help you get the latest software binaries for your XRCS environment. So I'm logged in here on my Exadata cloud node, compute node, and I did a Debus CLI CSW lib download. So that downloads like all the binaries which are new and not present on my software library. So before getting into this command, if you take a look at this screenshot, I have used command Debus CLI CSW list, right? So CSW list is going to display you what specific versions are there. And if you notice, my Debus CLI version is 18.2310. Means I have definitely updated my cloud tooling, which provides me the latest version of all the utilities, whether it's Debus API or CLI, or any changes or any enhancement we are doing continuously to the cloud environment. So they all come through the cloud tooling. So that is important step you should be doing before attempting this command. So in this particular example, if you see list of available bundle patches, right? And we have April 2017 till Jan 2019, and it is for all database versions 18 to 11.204, and we have another databases the 12.201 and 12.102 a specific April patch, and then Jan 2019 patch. So this is a complete list. Once you have the list, you can use the CSW lib download, and that is able to download all of the software, corresponding software. So if you see in my example, I have only got 11.204, 12.102 and 12.201 as downloaded, right? But if you see here, like we have 18C. So the simple reason for that one is like when I provisioned my XRCS environment, I selected my database as 12.102. So I have got the software compatibility till 11.204, 12.102 and 12.2, because my grid home after provisioning is not 18C, it is just 12.2. So here the tool is intelligent. It identified that I don't have a 18C home, and it has not even downloaded the software. But if you go ahead and like provision your 18CA starter database, so you get all the 4 homes starting with 11.204 till 18, and then all the tooling will be knowing what specific softwares to download applicable to your database or database homes. So we saw that like how to basically see what softwares are available and how to download. Few of the examples of Debus CLI could be Debus CLI patch tool list, for example. So patch tools list is going to basically show you all the latest tooling which is available for your platform. So as I said, like updating the cloud tooling is important, and one of the way could be using Debus CLI itself. And Debus CLI is a command line, easy to use. Just log into Debus CLI or do command as from root user Debus CLI patch tools list, and that will show you what is the latest cloud tooling available. So in my case it was 18.2.310, but available patch was like April 19 was the latest patch which was available. So once you know what tools are available for the environment, then you can install them using again Debus CLI. So Debus CLI patch tools apply -- patch ID and provide the patch name, or like just give the latest. So that way like you are able to upgrade your cloud tooling. So not only that, like several other example you see here. So let me, this is what like we already seen CSW lib download, right? And by that one I downloaded the software version which supports NonCDB. In my case, list, we have seen examples like it was able to list all of that. For just bouncing database you can use simple command. So wherever I have hash, that indicates the root prompt here. You would be able to see what database images you already have in software library. Any operation related to database like changing password or moving a database from one home to another home, starting database, looking at the status, stop, database updates, even it handles the rerule of related activities. So any listener control commands, they all can be managed using Debus CLI. You can stop, start, you can check the PDB, check the node. So PDB related operations. So this list is really long. I have just given you a few examples here, but the link which we looked at, they will talk in more detail. So as a use case, as I said, Debus CLI update your software library to include the NonCDB image, right? We already seen this. We issued a Debus CLI patch tools list, and with patch tool list, you are able to view the available patches, which are all of this. Then I issued a Debus CLI patch tools apply patch ID latest. So this is what like makes your cloud tooling to the latest. So in this example, what we are doing is like we are updating the cloud tooling using patch tools apply -- patch ID latest. So if this is the latest ID, like it will be applied in the environment. So these like patch the tools, the cloud tooling, they always get changed. So in my case, this is the latest one, and updated the Debus tools RPM to this particular latest one by using this command. The another thing is like patch tool list. From here, whatever options you are getting, you have ability to download any one of these from the list, and you will be using the CSW lib download in the version and bundle patch -cdb no. So this one is going to basically download that image and keep that in your software library. So this is the one like I was referring with my Debus API command, and in order to execute that use case, you need to download the image which supports a non-container database. So by default, Exadata Cloud Service creates an Oracle database 12c or later database using multi-tenant architecture with a container database and pluggable database. Many existing database, especially e-business suite implementation, they are using non-CDB database architecture. So that was the use case for which we provided non-CDB support on Exa. So we have discussed on Debus API and Debus CLI, and now we'll move towards another XRCS REST services. We'll talk more on the CLIs, OCI CLI specifically. So OCI CLI provides basically all of the operation which is possible from the console using this command line interface. So it uses all REST service calls, and that needs to be configured with proper authentication credential to communicate to OCI services. So there is an installation step which is involved in OCI CLI, and not necessarily this command line utility you are going to install on Exadata cloud service. It can be installed anywhere. So it could be either on a compute which is running on OCI, or it could run on your on-prem, your laptop, from where you are managing your cloud instance, Exadata or like any OCI services. So it supports various operating systems like Windows, Linux, and you can use either of them. It also provides the tooling and APIs known as REST API and CLI APIs. REST APIs, as we know, like it helps you communicate between two systems on a network, and they basically make a request to a particular URI, and response being in HTML or JSON or XML. Operations are predefined by HTTP methods, and all of these 4 get, post, put, and delete operations are supported. So we'll look at what OCI CLI provides with respect to Exadata cloud service. So some of the example could be managing backups, recovery, controlling the Exadata IORM settings. IORM is an important feature on Exadata cloud service, and it is supported by OCI CLI. To manage database deployment, you can use OCI CLI. You can manage patches, you can manage snapshots, you can manage the compute node operations, see the service details. Like for example, you want to know like how many VCNs you have for your XRCS environment, or how many subnets it has, or what are my users there. So all of those activities can be performed using this OCI CLI, and this link below will give you the latest information, all the supported functions through OCI CLI. And now we'll go ahead and like look for how to install this and use them. So for OCI CLI installation for accessing REST APIs, there are certain steps which has to be followed. So you will have to open up the Linux terminal. As I said, like you can install it on a Windows machine, but in this example I'm going to do it on a Linux. And then specific to operating system, you have the commands. So the command here to run the installer is bash-c curl, and it gives you a location of the install.sh script. So choose the directory where you want to save the executable and a script of OCI. You need to make sure that internet connectivity is there in order for OCI CLI to get installed. Linux operating system should have, in my case I'm using Linux. It will prompt you to update your path, and then you can select yes in response to that. And after selecting the path, installation will become successful, and you will see the message means this is the only input for installation. It just confirms the path where OCI CLI is going to be installed, and then you can always use the OCI CLI prompt or help, and if things are configured properly, you'll be able to see the help related to OCI CLI. So it is downloaded and installed. Sorry, and we need to configure it for the Oracle tenancy. So the next step, as I said, once the installation is done using the previous command, you would be able to validate it, like OCI -help will show you something like the uses, and it clearly says that installation was successful. So after installation, you should configure your OCI CLI to connect to your instances, and these instances could be your Exadata cloud service instance, or like any compute, or any other resource on Oracle Cloud Infrastructure. In order to configure this CLI, you basically use a command called as OCI setup config. So you can accept the defaults for config locations and need to provide several other details, which I'm going to show you in next screen. So you can find that this is in the web console. So few of the inputs needs the user detail, and from where you will find that, like, you will log into the console and get the user details, and for doing that you have to go to OCI console under identity users, and you would be able to select the user and copy values for this particular setup. So continuing from their configuration, so OCI setup config will ask you location for your configuration file, and then after giving that location, it is going to ask you enter the user OCID, and user OCID is obtained from the console from identity and users, and select the user for which you want to configure this CLI. Then it will prompt you to give a tenancy OCID, and the tenancy OCID is obtained from the console under administration and tenancy details. After that, you will see it is asking you the region, and a region is nothing but like whatever is the region where you have your services in. So in my case, like US ASP.1 1 is my region, and I will pass that value to configuration. Then it also asks for a new RSA key. If you already have, you can use that, or like if you don't have, just type yes and it will generate one for you. And that RSA key, like, you will be basically providing that within your console, and there is a configuration step which you need to do. So after generating a new private key, or after specifying the path of your private key, you should add the corresponding public key in the console. For uploading the public key, navigate to the user under identity, and then you will see an option that is called add public key, and there you have to paste that one and save the configuration. So I have examples of this one. So here I'm showing you how you will know what is my OCID. So when you log in, you can see the user information and click on the OCID. You can copy the value which will be needed for OCI setup config. Tenancy information, you can navigate to the instruction I just gave, and you will be able to copy the tenancy from there. Adding the public key, again, you have copied the public key from there, came to this place and pasted it in the console. So it must be in the PEM format, and when you generate one, it makes sure that it is in the format which is required. So for doing that one, API keys here in this example, it shows that I have one with a fingerprint, and that's added, and it helps complete your installation. So this is OCI CL configuration example which we just discussed. So I'm doing it on one of my application hosts, not directly on the XRCS, but once the installation is done, I will show you like how you can connect and start using the XRCS related details. So OCI setup config, it asks the user OCID, region and general. So you have accepted the location for your configuration file. I accepted the default, or if you want to give a new directory, you have to enter the OCID which I got for my user, then the tenancy OCID and the region. And region could be one of these: US, Aspen, Phoenix, London or Frankfurt. And it has asked me that you want to generate a new RSA key pair, and I opted for yes. And then it created these keys like API key public.pem and OCI API key .pem. So this was my private key. So private key and public key pair was generated within my the location which I specified, and you are taking the public key from here, content of that, and you have applied that inside the console. So this you have to just copy the value of the public key from here, OCI API key public.pem, and navigate to the console identity users, select the user and the API keys, and add the public key. So once you do with this step, public key addition, the configuration is complete, and you would be able to connect it to your tenancy. So once you are done, you can also take a look at this URL, which has information about OCI command line, but you would be able to connect and do any activity. In this example, I'm showing that OCI network VCN list -c, and I'm giving the OCID of that one, my tenancy. So it is able to list me out my compartment ID, the CIDR block which I have used for my VCN, my DSCP options, my routing table, security list. You can additionally format the output which comes out of this OCI command. So for example, OCI IAM region list -- output table. So it will provide you a formatted output for the command. So using the CLI, you can perform pretty much all the operations which you are able to do from the web console. And only thing you have to make sure you have the privilege for the operation you are trying from the OCI CLI. For example, you can list all the virtual cloud networks in a particular compartment. So OCI network VCN list and compartment ID. So it will list all the VCNs within this compartment. These are few of the examples how you are going to use that. You would be able to list the subnets like OCI network subnet list -c. So it will list you within the compartment ID what you are providing here. You have specified the VCN ID, and it will list you all the subnets within that. Here I want to know my all the database list within the compartment, and we can use the command like OCI DB database list. You have to pass the compartment ID and the database system ID. So I have passed database system ID, that is nothing but the OCID of my database system, basically Exadata system, and then it is able to tell me all the details related to my environment. So database name is BMS prod. In this case, it is a OLTP database. There are no backups enabled at this point when I captured this input, and compartment ID, character set, and all of these details. So output is just truncated, but you are able to see all the databases which are there in Exa CS. So now we'll take a look at few of the operations which OCI command line helps you with. So creating and deleting a database, for example. So you need not to basically go and do it from console. You can do it from command line from any machine which has OCI CLI installed. So command is simple: OCI database create. You need to specify the database system ID, and this OCID belongs to my Exadata cloud service. You have to specify the admin password. Provide a strong password, database name and PDB name, and database version, which version you want to create. So depending on how many Oracle homes you have during initial provisioning, like you can do either 11G database or 12.1 or 12.2 or 18. So some of the other parameters here, like character set or compartment ID. So these are related to your database, like character sets and all of this. And so you would be able to basically provide this command, and then it is going to do that activity, and you would be basically able to track it. Like you can go to the console and check like if that database is getting provisioned. So when I ran this command, I looked into basically the console, and this console is showing me this database is getting provisioned. And same thing is like you will see in the command prompt as well, which we are able to see here. So all of the database details, the only required parameters was the database version, name, PDB name, and all, but remaining other things it takes from the command, and it shows you like time created and the different details, like whether it's what kind of workload it is, or what is going to be the database unique name. So all of these details will be populated as output. So this one we've seen how we can create the database. You can also delete a database by using OCI DB database delete. So here you will have to pass the database ID, and that is the only parameter is needed for deletion of the database. So uh, these are the commands we seen, like how they help with dealing with database creation as well as deletion. We'll look at few other commands, like patching operations are also supported by OCI CL. You can patch, you can backup the database, you can create data guard instance, control the IORM settings for your Exadata cloud service environment. Uh, any feature you are able to do in OCI console can be pretty much performed by OCI CL. So we'll take another example of patching. So for doing any patching activity, like you need to first find what are the patches available for a particular database, and you can see the patches for an individual database as well as the grid infrastructure patches. So how we do it, like just use the OCI CL, pass the database system ID, and this is what I'm doing. So list by OCI DB patch, list by database, database ID, and specify the OSID of the system, and it would be able to show you like all the available patches for the XRCS environment. Once you know what are the patches available, you can go ahead and use patch that system. So for example, database patch, database ID, OSID I have given, and then patch action is pre-check, because first, before even applying a patch, you want to do a pre-check to make sure things are fine. Specify the patch ID along with that, and it will tell you like if database is ready for patching or not. And then like you can again use the apply here as the argument, and then it will be able to patch that particular system. So not only that, you can scale your OCPUs of Exadata cloud service. So we can scale a service to the OCPU count we want to use, and again, like you will be using OCI DB system update -- CPU core count, and core count is going to be the value you want to set. Like XRCS, as I said, it supports basically 0 to 92, even in a quarter rack, right? So if you want to set it to 2 or 4 or 16, you can do that, or you can go up, or you can come down. You can make the count to 0, which will shut down the database. So this example is setting the CPU core count as 4 in my example. So it will immediately this activity will be carried out, and you will be able to again query. If you use the system get call, then it will tell you that what is the effective value of CPU core count in the XRCS environment. So now let me move to Exa CLI, and the Exa CLI is used to execute a specific cell CLI commands, because one thing, as you know, on Exadata cloud service environment, you don't have direct access to storage cells, and storage cells is managed by operations, but you have a read-only view, and that read-only view for most of the useful commands is through Exa CLI utility. So you can perform monitoring as well as management function on Exadata storage server, which is associated with the XRCS environment. So you need the cluster name in order to use Exa CLI. So the first step is find out the cluster name of your XRCS installation. For doing that one, you will have to log into grid user. So log in first with OPC user, sudo to grid, and use crctl command get cluster name, and it will fetch you the cluster name of your XRCS instance. So once you have the cluster name in place, you can use Exa CLI API, and this example here which shows Exa CLI --login name, and then cloud_user_cluster name. So this is going to be your standard syntax for any environment. Use cloud_user_ the cluster name which you have got from crctl command. So that is the user, and then --cookie jar, and then -c. This IP address here is one of my cell storage cell IP address, so that you can very well find from your cell ip.ora, or like from your host file should also have an entry, I believe. So you can find like in a quarter configuration you have at least 3 storage cells, so you'll be able to find the IP address of that, and you can pass that one for connecting to or using the Exa CLI command. So it will ask for the password, and this password is nothing but during provisioning of XRCS environment you have provided a password, right? It is the same password like which goes with admin like system. So provide that password and it will come up with a prompt, and once you have the prompt available, you can issue any command like list grid disk details or list cell disk, list flash cache, you can list the IORM plan, flash logs, you can deal with your PDBs, pluggable database here. So all of these commands can be executed once you have got the Exa CLI prompt, and this is the only way you are able to basically get into a storage cells, right? Not directly, but kind of read-only access to these commands. And Exa CLI has a long list of command which it supports, so these are just for few examples, but you can deal with cell, you can deal with alert history, database, you can find like what is going with flash cache or flash log, whether IORM is enabled or not. You can deal with different metrics on that. About any physical disk you can do queries, you can set or look for the thresholds. So several operations which are possible can be done using Exa CLI command. So this was my last topic, so I will take a pause here. I will get into my demo before I conclude the basically this topic. So let's get into the demo. So let's get into the demo. To start this demo, I have logged into one of my compute node through OPC user. So from here, I will navigate to root user. Because most of the operations we are going to perform are administrative in nature, means I'm going to show you the way you will be updating your cloud tooling, and again for doing that you need to be root as the user. So first try to find out what cloud tooling version you have on your XRCS environment. So for doing that one, you can always use the RPM grep command, and you have to look for Debus tools underscore Exa. So here if you notice, the Debus tool version on my platform is 19.04.09. So this is the version which is available, and we need to definitely know what is the latest version available here on XRCS. So for finding the latest version, you can either like go with the xrdbc patch sm command. They would be able to list it out. So let me use that command. And here I'm again going back to my xrdbc patch sm folder, and that command is going to list out the available patch for this XRCS environment. So if you notice here, it is saying that my current version of cloud tooling is 18.231.19.04.09, which is pretty latest, like not very old, but it has also found another patch which is available for the environment, and that is 19.04.15. So definitely this is the latest patch available for my environment on XRCS. So I will show you how to update this one. So before doing that, like updating is simple. We can go ahead and like give a command using xrdbc patch to update this. So this command is going to is just like this, give the tool inst and rpm version equals to latest, and you can remove the latest keyword and you can specify the exact patch ID which is available here on the screen, and it would be able to update that one. But before going to that, I will show you, you can also use additionally Debus CLI to do this activity. So for Debus CLI, command is going to be Debus CLI patch tools list. And again, Debus CLI, it is going to use the XRDBC patch internally, but it will come up with checking on all the nodes that what is my current tool version, and then we would be able to apply that tool. So another thing you might have noticed that it is going to check these tools on all of the nodes in my XRCS environment. So this is a matter of choice, like you can use any tool. If you are going with the first one, using XRDBC patch, you will have to do this activity, update activity separately on all the nodes in the cluster. Otherwise, like if you go ahead with the Debus tool, you can specify like patch the system, and it will take care of updating those tools at both the cluster nodes. So here again, like as expected, it has found latest patch set version, which is the latest, and the tool also provides you how to apply that patch in your environment. And it has come up with like Debus CLI patch tools apply patch ID, or like you can use the latest keyword. So by using this one, I would be able to update the Debus tools which is needed for any activities, like either you are doing patching or upgrade operations, or you want to use different APIs and CLIs. So it is a better idea to update it. So since like we have the command available, I will use this approach and try to update my cloud tooling from here. So this might take some time. We'll wait for a minute and see like if it comes out. But this is what it is going to do. Like it is looking for the version which is already there, and it found the latest version, and it is going to take an action and apply the latest patch set in my environment. So since this tool might take a minute or two, so meanwhile I'll bring another terminal and try to show you if we can run a few other API related commands here. I will log into my accelerator node, and in this example we are going to do Debus API, and by using that Debus API we will try to create a non-container database. Just to give you a feel on, like, process is going to be same whether it's a container database or non-container database, but I will be creating a non-container because that is the latest feature we added on XRCS environment. So I will do the preparation stuff for using this Debus API here, and for doing I will navigate to my directory. So first let me go to root user. So one thing, like OPC user can do sudo to any user, and I had a mistake in the syntax, that's why it prompted for the password. So I have done sudo to root, and I will navigate to the directory where I am going to create the input files for Debus API. I have already created a directory over here, and I also have few files which I am going to use for my database creation using Debus API. So the first thing for creating this database, I'm going to use this createDB NonCDB.json file, which I have created for just for demo purpose. So let me show you the content of that. So here I have specified the object as database, the action is going to be start, and operation is createDB, and different parameters I have provided here. CDB is going to be no for a non-CDB database. I'm going to use the bundle pass Jan 2019 which you will see like the method to download this to your software library and using Debus CLI command. But I have already downloaded it, so I'm going to use that for creating this database. I have given this database name as training. The version is E_EP. Version is 12102. The admin passwords which I'm going to use for database creation, the character sets, backup destinations, and here backup destination is saying that I want to have the database backup on Oracle Object Storage Container. Then I have cloud storage container with the URI, and that is nothing but the object storage with a bucket already created. So I have a bucket which you see here is available on my in my tenancy. So I will just verify it quickly that like is the bucket name is correct, or then like cloud storage user, it has to be the user which has the access to object storage and the auth token for your user. Then at the end, like I'm specifying the output file from this command, and this file is going to be under the same directory with name create_db underscore noncdb.out. So this was the first step of creating this input file. You will have to make sure that there are no syntactical errors, so this colon and the key value pairs are correctly specified in this, and then we can go ahead and like run this command. So for doing that, I'm going to execute var opt oracle dbas API and dbas API inside, and with the argument as create_db noncdb.json. So this is going to invoke it, the script, the JSON file which I have already created, and it will give me a command output which is specified within this JSON file. So what I need to do is like I will be looking at this create_db noncdb.out here. So let me cat this file and see what is the content within it. So if you notice here, this is it says first thing is like for security please remove your input file because they are no more needed now. And another reason is like the input file had the credentials for your object storage and sensitive information in it. So it is a good practice to remove that one. The object is DB status, it is showing as a starting, and output file is the same which we have specified in the JSON file earlier, and it has given a process ID. This ID is 50 here. So this is going to be used for further tracking the output of my Debus API create database operation. And the operation is create_db, and there is additional log file which is available here which can be tracked, and this should also show you what is going on behind the scene. So it does several checks, and then like this will be progressing, like it will so the values are changing, and we can again, like since we have already received the process ID here which is 50 in my case, so I'm going to keep this one in the file which will be used for status tracking. So I will create a create_db status.json in the same directory, and I believe like it should be already there. So let me take a look at if I have already created. So I have created a create_db status.json file, and let me show you the content of that. So this is the second step. So first step, we created the JSON file for database creation, we ran it, and then we got the process ID from the out file, and based on that we are creating this create_db status.json file. And in this one I have already specified the object is DB, action is status is what we want to monitor now, operation is create_db, and only thing I have to change is the ID value, which is going to be 50 in my case, and database name is training. So output file, again it is going to be same, create db noncdb.out, and that is the only change. So I will save this, and then I will execute another command to see the command output. So here, if you notice, I'm just passing this create dba status.json, which we have just now created. And then again, we will have to look into the output file. We will cat this file, and here if you see, now the message has changed. It is showing that it's in running OCD phase, and object is database, status is in progress, and there are no error messages here. Out file is home oracle db input create db noncdb.out, and now we have got an additional process ID, which is PID. So this is basically the OS level process ID, which has invoked internally, and it shows operation as create db. So this particular input is going to change, so we will have to monitor this one several times, and at the end, like, you should see the status as like it's already created. So let me check like if the P1 process associated with this database instance create training has come up or not. So right now it has not come, so it might take some more time and before it get executed. But once this progresses, you would be able to see, and that one, like, there will be a corresponding P1 process here, and that would be able to show you that database has got created. So let me check like if my previous API output is done or not. So here it has updated, so it says that like it was executing the command patch tool apply, patch id latest, current tool version, and patch id to apply was the latest, updated the Debus tool RPM to the latest one 19415. So these updates are done. So current tool version is on node 2 is showing up as this one, and the node 1 has not yet come, so it might be applying that also. So here, in order to track the progress, this command has to be run several times, and you would be able to see that there are corresponding log entries are getting generated, as well as there are P1 processes and other database processes started. So another way to test is like definitely the log file which we saw earlier with the process ID 50. So that will give you a fair idea on if there are progress or not. So here we see that it is still progressing, which might take time. So we will get into the other topic we wanted to cover as part of demo, and that is going to be Debus CLI. Later we can again come back and check the status of the database on this node. So in order to use Debus CLI, you have to enter Debus CLI on the command prompt, and then it provides you Debus as your CLI, and it also shows you the version of the database CLI utility, and in my case it is showing as 182310. So that is the version which you also see from the Debus tool RPM, right? So it's 182310. So once you are in Debus prompt, you can use several commands which are used for managing the database lifecycle. So one of the things could be just database status, and as you know, like this if CLI expects hyphen hyphen DB name as the parameter. So provide a database here and see how it gives you the status of that. So basically it is going to provide how many instances I have for my database and where exactly that is running. So it says instance BMS prod 1 is running on node XD prod N53 machine, the first node, and there is another instance which is running across my second node, and their corresponding Oracle home it is showing in the command. And it also tells you basic details like it is 12C extreme performance version of 12.1020. So this was just a simple command to see how we can manage the status. You can stop the database, you can start the database, you can deal with the listeners. So think of like I want to know about DB home, for example. So DB home info, then if you will not give any argument, it will show you all of the database forms. Otherwise, you can always specify for which database you want to know this particular information. So this is what it says: enter a home name or just press enter if you want details of all the homes. So I press enter here. And it should be able to provide all the database homes which I have on my Exa CS environment. So here it is. So it says the home first home is Aura home 103.12.102 with a DB patch version. So this is important, a database bundle patch version. This also helps you know which image or database version you have in your environment. The home location it shows, as well as like it will give you the patch level of that one and what databases are installed. So this second one which I see here is showing the database installed as nothing. So definitely like it will be the one which is just getting installed, and that is the NonCDB script like we ran using our Debus API command. So database is not yet entered in the Aura tab, so that's why it is showing it blank as of now, because it's still in progress. For all other databases, it is showing me the home. Like I have a BMS prod which is installed under DB Home 2. I have ExaDB installed in DB Home 4. So all the details related to database home, it was able to show me. The another thing like you can check on like patch tools list you have already seen. So we will run some other commands. This could be csw lib list. So this is the software library on the system, right? So as I said, Exadata Cloud Service provides you updates in two ways. So one is through images, the other one is through regular patches as per the mouse note. Like every time, like every 3 months, like we provide you different patches available for the platform. So this command csw lib list is listing you out what patches or bundle patches are available for the environment, and this is starting with April 2017 till Jan 2019, and this is across all the database versions like 18C 11.204, and few are specific till 12.201, right? So another thing, if you notice here, is like list of available non-CDB bundle patch, and here we have April 2018 for DB version 12.201 and 12.102 version, and also Jan 2019 for DB version 12.201 and 12.102. So since like I don't have a 18C grid install, or that was during provisioning, I just selected 12C as my compatibility. So it is not showing me anything for 18C database version. But these are the ones which are available for me to create in terms of non-CDB. But for creating any normal database, multi-tenant database, you can pick any one of these. So ideally you would be interested in the latest one for your specific database version. So if you want to basically download one of these, so the command is going to be simple. You will just issue the cswlib download, and then you need to specify the version and the bundle patch tag. So command will, I don't have to provide this Debus CLI, I have just copied. So this is going to be the syntax. You specify the bundle patch with the tag which is available here, and it is --cdb no will make sure that software gets downloaded. So since I already have this bundle patch downloaded in my software library, it is going to show you the message that it's already there. So idea is like Debus CLI can be used for several operations, whether it's patch management or database operations dealing with database forms. So you can use this one for getting that database operations done. So now what I will do, I will move to another API which we discussed, basically CLI, Exa CLI, and show you how to do before I move to the OCI command line interface. So let me go out of it. And if you remember, for using Exadata CLI interface, you need to know what is your cluster name, and cluster name you can always find from your grid infrastructure software. So let me go to grid user first, and then show you how to get that. I'm into grid user now, and now I can issue a command like CRSCTL command, and it came up with the current cluster name is XDP cluster -035. So this is my cluster name which I am going to use with my Exa CLI command line. So for accessing Exa CLI, we can log in from OPC user or Oracle user. So I will go out of this grid home. I'm going to my Oracle user, and then so in order to use Exa CLI, you have already got the cluster name, and the syntax is Exa CLI -login name. Then the user is constructing using the grid cluster name, and that is like cloud_user will is the prefix, and then we'll add the cluster name in it, and then --cookie jar, and then -c followed with the storage cell IP address. So you can specify any storage cell IP address, and basically within an Exadata environment, depending on the configuration and shape, you can have multiple storage cells. So that can be found in cellip.ora, as well as in the host file. You'll be able to find the storage cell detail. So pick one of that, and you can enter. It will ask the password for your Exa CLI, and the password in this case is going to be the same password which we have used while provisioning the initial starter database configuration. So that was the admin password for session system, and the same password you have to provide here. So I have specified the user password, and then it asks me that do you want to accept and store the certificate. I'm going to store that one, and after accepting, you are in the Exa CLI prompt. So now we can use any command like list grid disk detail, for example. So it has listed all the grid disk which is available in my Exa CS environment. So basically any command which can be used with cell CLI can be done. Only thing is like it is a read only. You cannot change several parameters we normally can be done with the cell CLI command. Uh, you can track the status of your Flask assay, and it says that like this is normal. You can also list your IORM plan if you have already enabled. So it says the IORM plan is active for my environment. You can use maybe a list flash log, and it should be telling you like if the status is normal or not. You can there are several commands which can be executed using Exa CLI. We have already discussed in the concept before, so you can try with various operation and see like how they help with the information needed from the environment. So here we've seen that Exa CLI is used for getting mostly the storage cell related details, and with that one I will move to my another example where I wanted to show you OCI CL. So let me go out of this, and I will log into another machine where I have already configured the OCI CL. I believe this is my, this is one of my compute node which is running out of OCI, and I configured the OCI Commandline utility on this. So I'm not going to show you how it can be installed. That could be a lengthy process. It might take time. So I will straight away assuming that you have OCI CL already installed, and I will show you the usage of that. So OCI help is going to show you if you are able to execute this command, it means OCI command line is already set. And another thing you can check here is I'm in the directory home OPC, and since I provided OCI installation directory as the same, so here I can navigate to OCI directory, and there are several files under this. So one is the configuration file, then I have the PEM files which I need to I might have provided into the OCI console during configuration. So this configuration file will have information about how you are going to connect with Oracle Cloud Infrastructure, and you can add multiple environments. So think of like you have multiple tenancy, you would be able to access that one. So that can be achieved easily through this config, and let me show you. So I have two profiles here. One is my default profile, and the other one is profile 2, and both are dealing with two different user IDs. Basically, if you notice, the OCD is different in both the cases, and they belongs to different tenancy. So the profile will have information on the user, the fingerprint information, the key file, that is nothing but the public key PEM format, and then the tenancy information and the region information. So this list can be longer depending on how many environment you are dealing with, but by default commands will be executed whatever is listed under default profile. So you don't have to specify, but if you want to access the another profile which is not the default one, you can specify the profile name while executing the OCI commands. So since like my OCI binaries are already installed, I have got my tenancy or compartment details. So few commands could be like OCI network VCN list -c the compartment ID OCID. So this is my Exadata compartment, and you know how to get the OCID from the console. So I will be able to list out all the VCN which I have created for my deployment, and this is what you see from here. It is showing me the VCN_BL, which is part of my tenancy. So this is one of the way like I'm able to get the VCN information. It shows me what is my CIDR block here, the compartment ID. I'm using default DSCP options here, my route table OCID, my security list related details, So pretty much all the details. I have some more VCNs for demo purpose. It is listing out all of them. Uh, I have uh, so now let's take a look at like how we will deal with the database systems since we want to see how it works for Exadata. So another example here, I want to list the databases within my compartment ID, and I have provided the compartment ID here and the database system ID. So any Exadata system is going to have a database system ID that will be nothing but a OCID. So that as well as the compartment ID. So it should be able to list all the databases in this one. So you see here I have a database bal test which is in my tenancy on the Exadata. Then other properties associated with that database is shown, like whether it's OLTP or what is the database unique name and all of that. Then like I have another database which is BMS PDB. It is part of like BMS prod. It's a container database here. So you see that detail. I have few more no, so it shows like me the two databases which I already have in my tenancy. So if you want to create a database using OCI DB, that can be also done, and commands are really simple. You can specify OCI DB database create followed with DB system ID, which we know like it's the OCID of the Exadata cloud system. You have to specify the admin password, give any strong password, then database name you have to specify. If you want it a multi-tenant, you can specify the PDB name here and the database version. So this example is going to create a database. So again, database creation, it is not just a PDB creation. It is a full-fledged database. Home will be created, a new home to have this database, since we are not supporting shared homes as of now. So it will be a time-consuming process, but that's why I'm not going to execute this here. I will show you another activity which you can perform. So many times you have a need of like updating the CPU core count for your, if you want to basically scale on XRCS environment, scale up or down. So the syntax are like OCI DB system update, and then you need to specify the CPU core count here, and you have to also provide the database system ID. So if I make it to 4, right now I believe like I have set it to 4, 2, and I want to move it to 4. So this will show you that all the details which it is going to do. So this year quarter rack 2.92 configuration, I have a sparse disk group and all. Somewhere it will show you how many I already have, and so I have CPU core count as 2 initially, and that is going to make it 4. So this operation will take a minute, and then you should be seeing that in console also. You can verify that the CPU count has increased, and database will be in updating status. Though you would be able to connect your application, all the activities will be done as normal. It is just about enabling more CPU on the environment. So with this, I'm going to summarize this session. What we have seen in this particular module is what are different options on REST API which are available for Exadata Cloud Service Operation. We discussed about Debus API as well as Debus CLI, and also looked at few of the operations which are supported by them. We got an understanding on how to configure and install OCI CLI, and some of the basic operations which can be done. So we seen it through example, and we also discussed about Exa CLI component, and seen some of the use cases of that one. So I hope you find this video useful, and for more details you can always go to our cloud portal, and I will hope to see you in my next video on XRCS topic. Thank you so much and have a good day.